Hello guys, welcome to our channel. I am Lara, and in this video we are going to talk about two-stage transportation models with GAMS. If you haven't watched the first video, please first watch that so you know which example we are solving. So when we are solving with GAMS, we all start with the indices. So here's our sets. Okay, so we got three indices in the question for customers, warehouses, and factories. So I is in this for factories. Okay, and then we have factory 1 and factory 2. Then we have in this J, that's for warehouses. Warehouses. We have two warehouses, warehouse 1 and warehouse 2. Okay, and then we have in this K, and that's for customers. Customer. We had three customers: customer 1, customer 2, and customer 3. So we are done with this cluster with sets. So we are putting a Oxford comma. So now we are going to write our parameters. Our parameters were the supplies, the capacity, and the demand. So supply of what? Of factory. So I'm saying SI, and then what is the how much is factory 1 going to supply? 100. How much is factory 2 going to supply? 150. Okay, and then we have demand. Who demands it? The customer. So we are using the index K. So customer 1 demands 80, customer 2 demands 90, and customer 3 demands 80. And then we have the capacity constraints of the warehouse. So we are saying J. So warehouse 1 has the capacity of 120, and warehouse 2 has the capacity of 130. Okay, so because we're done with this cluster also parameters, we are putting in Oxford for comma. So table for costs. Cij was the cost from factory to warehouse. So warehouse 1, warehouse 2, and then factory 1. So from factory 1 to warehouse 1, it costs us $4. To warehouse 2, it costs us $6. Factory 2 to warehouse 1, it costs 5, and to warehouse 2, it costs $3. Okay, so next table DJK. So that means from warehouse to customer. Okay, so customer 1, customer 2, customer 3, go down, and then warehouse 1. So from warehouse 1 to customer 1, it costs us 3, and then 4, and 2, and then warehouse 2, it costs to customer 1, 5, 2, and 6. Those are obviously unit per unit costs. Okay, then we have our variable. Variable here is only z. And then we have positive variables. When we write it this way, this is then the non-negativity constraint that we have when we are doing it manually. So we don't have to write a non-negativity constraint. Okay, then we get our equations title also. So I forgot this one. Okay, so we had normally 5 equations, but for the last one is here now. There's no non-negative equation, so we have 4 left plus the objective function. So first objective function, then we got our supply constraint, the flow balance constraint, demand constraint, and facility capacity constraints. Okay, objective function dot dot. So z equals to say equal to, we say equal sign, equal sign. And then we are going to sum. What are we going to sum? ij, comma, And then we are going to say Cij, cost of um, uh, factory to warehouse times the amount of unit we are sending plus sum of JK, oops, JK, DIJ, the cost of sending from warehouse to customer, times the amount we are sending from warehouse to customer. And don't forget your Oxford comma. Then we have the supply constraints. Okay, so for the supply constraint, we sum J, um, X, of course, X, I, J, and then this has to uh, be less than or equal to the supply amount, SI. So, and we are missing something here, and that's actually the summation sign, let's say, for I. How do we do that? We put it here, I, and then we put it also here. Then it shows that I is also going to increase. And then we have the flow balance constraint, and this is, we'll come to that, and okay, so we are summing I, Xij, Xij, and then this is going to be equal to, again, equal to Y, okay, sum of JK here, of course, and then YJK. JK. Okay, so here again we have K, we have I, but we don't have the J, so that's where what we're going to put here, J, J. Yeah. Okay, then we go to the demand constraint, but first don't forget the Oxford comma. The demand constraint. Okay, and now we are going to sum um, Y JK. And this is going to be greater than equal to, of course, what we are going to bring from the warehouse to the customer has to be greater than what we are going to give to the customer. We also have to have something at stock. The demand. Okay, so we have. Okay. No. J. Okay. And then, and we have done this, and how is K going to increase? We're going to put the K here. Okay, now this makes sense. Okay, then we have the next constraint, FCC. So the facility capacity constraint. Let's write that down. Sum of I, and then we're going to say X, I, J, and that's going to be less than or equal to capacity J. And then we're going to put J here, because how else is J going to increase? Okay, and then now that we're done with the constraint, we have two equations, we have to solve it. So we're going to model, let's say new one and all, and then we're going to solve this using LP minimizing. What are we going to minimize? We're going to minimize Z. Okay, hopefully there's nothing wrong. There is something wrong. Let me look at it. Okay, now there were a few parentheses issues that I solved, and I had written IJ here. But now this is the last code. Let's yes, okay, so this is working now. This is the last code. As I said, some parentheses issues. Okay, this is how you write an GAMS model for two-stage transportation problem. Okay, so let's read the solution. Let's see. Customer 1, there is 40 units delivered. Warehouses, customer 2, there's nothing going there. Warehouse 1 to customer 3, 80 units. Warehouse 2 to customer 2, 40 units. Warehouse 2, customer 2, 90 units. And warehouse 2 to customer 3, there is no units going there. And then we have factory 1 to warehouse 1, 100 units. And to warehouse 2, it doesn't go. From factory 2 to warehouse 1, 20. And from factory 2 to warehouse 2, 130 units. So this is the GAMS model, and this is also how you read the model. Thank you for watching the video, and I'll see you next time. Let's see.